Okay, we have a survey that finds that 59% of employed adults believe that if they lost their job, it would be easy to find another with a similar salary. Suppose a random sample of 8 adults is selected. What is the probability that more than 3 people in the sample believe they could easily find another job? Okay, so first off, what we have is a binomial experiment with n equals 8 trials. Right? We're going to pick 8 people at random, right, and ask them if they believe that they could easily replace their job with another one with a similar salary. And so we know, right, they tell us that the probability of a success, right, and by success we're saying that the person believed they could replace their job easily, then the probability of that is 0.59. So we have 8 trials, and the probability of the success, right, that people believe, that is 0.59. And so what they're asking us for in this problem is to calculate the probability that more than 3 believe. So sometimes when these problems, especially if we're going to use the calculator, sometimes we're going to have to rephrase the probabilities because of the way that the calculator works. And so sometimes it's easier just to stop and take a second and think about what it would mean for more than 3 to believe, right? So in this case, right, for more than 3 to believe, more than 3 would mean either 4 believed, 5 believed, 6 believed, 7 believed, or 8 believed, right? We have 8 trials, so that's what we're calculating the probability of. The probability that 4, 5, 6, 7, or 8 people believe. Okay, so unfortunately, right, the calculator is not very good at calculating probabilities like that. We are going to use the binomial CDF command, and what that command is really good at is adding up probabilities from 0 up to a certain point. And that's not what we have here. We have from a certain point on. So what we're going to do is use the rule of complements to rephrase the probability that we're looking for in terms of something else. And what the rule of complements, when you apply that, right, it just says the probability that more than 3 believe would be 1 minus the probability of the complement of this event. So if it's not true that more than 3 believe, right, what it would mean is that 3 or less of the people surveyed believe. Okay? So again, it might be helpful to break it down into exactly the numbers that you're looking at, right? The opposite of this, if it's not the case that 4, 5, 6, 7, or 8 believe, right, then, or if it's the case that 3 or less believe, then that would mean that either 0 people, 1 person, 2 people, or 3 people believe out of the people that we surveyed there. Okay, so that would be the complement of this event. So sometimes looking at the specific numbers that you're looking for will help you in these problems, because sometimes it can be a little awkward to rephrase things until you get used to doing it. Okay, so now that we've rephrased it, the benefit of that is now we can use the binomial CDF command. It is really good at calculating the probabilities from 0 to a certain point and then adding those together, which is exactly what we need to do in this case. Okay. So how do you use the binomial CDF command? Well, you would turn on the calculator and then go to second and then click on vars, and that brings up the distribution menu. And then you would scroll down until you get to binomial CDF. And the C, right, the binomial stands for binomial. The C there stands for cumulative. So it'll add up everything from 0 up to a certain point. And so that's the one we want. And here we have 8 trials, so you would enter 8 in there. And then the probability of success is 0.59. And then for the x value, you want that upper limit there, which for us in this problem is 3. So you'd enter 3 in there, and then go down and hit enter, and hit enter again, and it would tell you that cumulative probability. So the probability that 3 or less believe is 0.1895. Okay, so you don't want to stop there, right? Because remember, we were after the probability that more than 3 believe, and we were using this rule of complements. So just make sure that you finish here. The probability that more than 3 believe would be 1 minus that probability that the CDF command gave us, and I have a little typo in there, so it should be 1895 equals. And on the calculator, you can easily do that by doing 1 minus, and then second, and then the negative key down here. If you look above it, it says ANS there, and ANS holds the most recent calculation that you have right there. And so click enter, and you can see to 4 decimal places it would be 0.8